Hello, this is Max working on Fall 2014 Final Exam, question 5C. It's an orders of growth question, and we're asked to circle the theta expression below that describes the number of calls made to fiblink.up2 when evaluating fiblink2, fiblink1.up2n. The constant phi is blah 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 1.618. Alright, so it's an orders of growth question. Okay, so quick reminder on what fiblink.up2 is doing. It's generating a link of Fibonacci numbers that are greater than or that are less than or equal to n. So given some input n, and say 3, what I'm doing is I'm first checking to see whether or not my self.first is equal to n. In this case, it isn't, right? And then I'm seeing whether or not self.first is greater than n. So if I'd given you 1 or something, then I would want to cut off 2 because it's not greater than or equal, it's not less than or equal to n. And then I'm going to see whether or not I've overshot at all, or whether or not I will overshoot at my next shot. And otherwise I'm going to add another link onto this Fibonacci chain that's going to include a number that is less than or equal to n. So in this case we add 3, which is the next element in the Fibonacci sequence. Alright, cool. That's just a quick reminder of what that does. The next thing you might be asking is, okay, what is this phi? Well, we have to remember that Fibonacci is some function that has its own order of growth. And so Fibonacci is actually going to grow with this constant. And the way you can sort of figure this out is when I inspect this first element. Let's look at a chain of Fibonacci numbers. This is the first 5 Fibonacci numbers. When I look at this element 5 and see, just sort of plug and play, I do 1.618. This 5 is related to 8 by multiplying. It's a factor of 1.618 approximately less than 8. So I do 0, 4, 9, 1, 0, 3. We're going to get approximately 8.09. Right, so that's about 8. And if you keep plugging in different numbers, you'll find that this factor approximately holds. So whenever one way to calculate the Fibonacci sequence, another way to calculate the Fibonacci sequence, which is not exact, is you can take the element of the Fibonacci sequence that you're currently looking at and multiply it by this factor, and you'll get the next element of the Fibonacci sequence, approximately. So this is just good to know. You have sort of this is where this phi is coming from. It's not just some random number. And now, the way I would actually sort of approach this problem is I would kind of forget about, any constants that we're looking at. So you can sort of think about this as, this is a constant, this is some log n solution. The base doesn't really matter. This is an n solution, this is n squared, and this is some exponent. This is some exponential solution. So this is going to take a tremendous amount of time as we increase our do a tremendous number of calls as we increase our number n. So the way I like to actually solve these problems in 61A is I make a chart and do number of calls. So we can sort of see how our number of calls, which is the function that we're interested in getting an order of growth for, increases as our n increases. So we have a bunch of functions of n, and so let's see, as we increase n, how does our number of calls increase? Okay, so we looked at 1. If I plug in n is equal to 2, then I don't have to make any calls, right? Because I will have already constructed the maximum number of Fibonacci numbers that are less than or equal to 2. And now let's find the first number that gives us a call of 1. So 3 is the first number where we actually have to do an additional call, right? So I need to put one more link onto my chain. And now so there are a few possibilities. So as I increase this number, so one way to do this is you just double n. And if I double n, I should see a doubling of number of calls if it's linear. I should see in this case, once I get to 2, I should see it go faster than a doubling if it's either exponential or n squared. And I should see it going less than a doubling if it's not linear, so if it's a log solution. And if it's constant, I should get only one call as my n increases. There should be no relationship between n and the number of calls you make. All right, so let's take a look at this. If I have 6, how many calls to fib link do I need to make? Well, I need to make one to put in the 3. I need to make another to put in the 5. And then if I try to do one more, it would be 8, and so it'd be an overshoot, and so we'll have 2 calls. This is looking potentially linear, right? It may even be exponential. We haven't done enough numbers to check yet. So let's put in a 12. So I've doubled 6, and so I should expect approximately 4 calls. So let's see whether or not that holds. So we've got 1 call to add 3, 1 call to add 5, 8. Okay, so we're just at 3, so it's a little bit under. But that's nothing to worry about. These two are looking a lot less likely now, right? Right, so now let's double it again, and we were looking at 24. So we've done 1 call to add 3, 2 calls to add 5, 3 calls to add 8, and we'll have a 4th call to add 13, and a 5th call to add 21. Okay, so this might still be linear. So we had 5 calls to add to get to 24. And so it's a little strange because we expected it to be approximately 4 times greater than the number of calls we would need for 6. So it should be about 8, but it isn't. Let's try one more and see if we can figure this out. Okay, so we had 5 calls to get up to 21. We have 1 more call to get up to 34. And now we're going to overshoot. Oh, okay, so only 6 calls. So this is definitely not linear, right? Because as we're increasing n in a linear way, we're just doubling n each time. We should see a doubling of our calls if it's sort of expecting it to keep in some slope, right? This would be a linear graph. This is a log graph. This would be an n squared graph. And an exponential graph would be like, phew. Okay. All right, so looks like definitely not exponential, definitely not n squared, probably not n. And it's definitely not constant, right? Because as we increase n, we see an increase in our number of calls. So we'd have to go with this. All right, so if you have any questions about this, please post on Piazza YouTube, and we'll get them answered. Thanks.